Right, whereas yesterday all we did was we calculated the values out, kind of like we're doing in this table. Today we're going to see the pictures of the three functions. So yesterday was more just throwing things into a function and getting an output, putting an input in and getting an output. Today we're going to use those inputs and outputs with ordered pairs and get a picture. So this is kind of your notes up here. 2-6 is the three views of a function. So if you want to write that up here, three views of the function. Okay, and so when we're talking about views, we're talking about the equation, which we dealt with yesterday. And notice we're not using f of x here now, we're using y, but they're interchangeable. F of x and y they mean the same thing. They're both your dependent variable or your output. Okay, your table is the second view, and then your graph is the third view. So you have your equation, your table, and your graph, your three views of a function. Okay, now all functions you're dealing with you can express in that way. And this year you guys will cover about 6 different types of functions in this class. When you get to advanced algebra, your second year algebra, you'll cover about 14. Okay, so it's important for you to start compartmentalizing things. All right, rather than going, okay, I have this equation, and then that's completely separate in your mind from this table, which is completely separate from this graph. It works a lot better if you could actually think equation and what's its picture look like, and then the table is the piece that helps you get from the equation to the picture. Okay, and there's some different patterns we look for in the table. If you can relate all three of these things, then rather than learning, like this year, if we're learning 6 different graphs and each graph has, or 6 different functions, each function has 3 different parts, that's 18 different things. Versus if you can compartmentalize it and say, okay, a linear equation looks like this graphically, it looks like this in a table, and it looks like this in an equation, and you can put all that together in one, then you've got 3 things you're remembering as one whole item. So rather than remembering 18 things throughout the year, you're trying to remember 6 things. That's kind of your goal. All right? So right here we've graphed it, or they've went through and they've taken this table and they've made it into a graph. Right now I want you to read through those steps individually. Okay? Kind of try to follow along with them. And then here in a minute you're going to be explaining to the class, one of you or a couple of you are going to be explaining to the class what's going on there. Good. So the benefit of having 3 columns rather than just the x and the y, the work column is a really important piece. All right? How many of you have used a table like this before? Okay, how many of you have just used the T-chart where you have x, y? Okay. Now this year we're going to use this type of table quite a bit where we show x, work, and y. Even if they give us this, you can always draw your own table. The benefit of having this is that you show your work. So if you mess up somewhere where your work doesn't match mine or doesn't match your partner's, or when you're checking your work, you're like, how did he get 8 and I got 5 or something? You can go back and check that. Okay, so having this work column is an important piece. And notice when they did that, they have their x, they have their y. The piece where they put the work, that's just this chunk right here. It's in y equals form. It's the part that y equals. That's called our rule. Okay? So if you're taking notes on this, you may write there, that's called my rule. Okay, that's the piece you go through and you complete that. All right. Now how many of you find math real easy? Okay. So how many of you plan on getting 3 years of math in high school? At least 3 years. Okay, that's your graduation requirement. Okay, so good. All right, I'm hoping everyone. All right, so this is your first year, Algebra 1. Geometry is your second year. And Advanced Algebra is your third year. Okay, if you're an 8th grader, you have to pass the SBAC at the end of that, after the end of your third year. And in the third year, you'll still be using this. Like I said, we do 14 different functions. This type of table will help you through all of that. So if you're looking at this and going, man, that seems like a lot of work, well, it's a good skill to have. Okay, so this is an important piece for you. All right, step 2. Step 2, let's see who we got here. Dude, Trinity. Trinity, why did they pick those x and y values?
Because they came from order pairs.
They came in order pairs?
They came for like in step 2. If
Huh?
you look over on the right during step 4, that's where they got those order pairs from.
Okay, they did get those order pairs from there, but why did they choose these particular x values in this case? Anyone want to help out? Brendan?
Because it says graph the function, and at the end of that it says x equals -3. Like all that.
Good. They actually tell you them this time. Now, they won't always tell you them. Sometimes you have to choose them. But in this case, you'll notice what type of graph does this give us? Dude, I'm going to have to do this all year. Person 2, Annalise. What type of graph does this give us? What's the picture look like? Okay, I want everyone to connect the points on that graph. All right, Annalise, what type of shape? Not a rectangle. Ah. Okay, so this type of graph gives us this big V shape, right? Okay, so we've got a V shape. We're connecting from left to right. This is an absolute value graph. Absolute value graphs, when you have x and a y, that's a V-shaped graph. So if you're taking notes on here, maybe off to the side, showing absolute value, has a V-shaped graph. Dude, you can make the V into your graph. Okay, absolute value is a V-shaped graph. All right, now we're going to study 3 of those graphs. You're going to see 3 of the 6 that you're graphing this year. You're seeing 3 of them today. Doesn't mean we're going to explore them in great detail today, but we're introducing 3 of them today. One is absolute value. It makes that V shape. All right? So the benefit of having these values is it actually shows the turning point, which we call our vertex of our V shape. That's an important piece. If we don't see that turning point and we only see one leg of it, maybe like that piece, then it looks like a linear graph. Okay, so we want to make sure that we see those turning points if it's an absolute value or a quadratic, because they have a little turning point. If it's linear, it's just a straight line. Okay, so we're going to study 3 of them. We're going to study absolute value. We're going to study quadratic. And quadratic looks like this. It's a parabola. And it has a vertex as well. That's that turning point we want to see at the bottom or at the top if it's opening downward. And we're going to study linear. Those are the 3 different types of functions that we're going to see today. And linear is just a line. It doesn't have a turning point. The forms these come in, that's the picture form. The equation form would be y equals absolute value of x. Anyone know what quadratic is? TT, want to take a guess?
When it has like a square.
Yeah, it's like when it has a square, x squared. Y equals x squared, and it could have other stuff after it. It could have like x squared plus x plus 1. But the key piece is that it's x squared. Okay, and then we have linear, which is just y equals mx plus, anyone heard of this before? Y equals mx plus b. Yeah, linear. You should have studied that a bit last year in 8th grade. Did you guys study quadratics last year? Some of you? Who did? Just out of curiosity. Okay, so some of you did. All right. So those are the 3 we're going to get into. Those will be the first 3 that we touch on this year. You'll see all 3 of those graphs today, and it's just to get you used to using functions. All right. So that's step 3, or step 2, excuse me. We have our step 3, we substituted our values and evaluated for y. Step 4, write the corresponding x, y values in ordered pair. That's kind of what Trinity was referring to right here. Okay? We have our step 4. The benefit of having these points, what do we do with those points? Mackenzie, what do we do with these? Why write those out? What's that? I didn't hear you. Yeah, we graph them. Okay, the benefit of writing them out, x, y, negative 3a, is so that we can graph them over here. Okay, that's what we were working through yesterday, a bit more. Okay, we're kind of taking it to the next step. And then step 5, plot our points. All right, connect them with a line. That's your process today. Okay. Now, there will be some things that I'll have to pause you on because you'll struggle with it a bit. But a few things I want to point out. If you'll turn to page 2 real quick. Here's page 2. On page 2, it talks about quadrants. Now, quadrants, we used to talk about tons when we were graphing. I don't know how much you've heard about quadrants before, but a coordinate plane, a Cartesian coordinate plane, which is what this xy axis is broken up into 4 pieces. Okay, does everyone see the 4 parts? They're called quadrants. Quad meaning 4. Okay, this is called quadrant 1. This is called quadrant 2. That's Roman numeral 1, Roman numeral 2. This is called quadrant 3. That's Roman numeral 3, and this is called quadrant 4. That's Roman numeral 4. Okay, important for you? Well, first of all, the reason I put it in Roman numerals is because that's how most people write it. So if you're not sure, like if you don't know what Roman numerals are, you might not be going to Rome soon, and I don't think they still use them there. However, you'll see them in books like that, so you kind of have to know at least that's how you write 1, 2, 3, 4. Okay? Quadrants we won't talk about a lot this year, but we'll reference them every once in a while. So know where quadrant 1, 2, 3, and 4, and in this one it says name the quadrant they're in. So it's important for you to know them. Okay, it's a good reference point. If I say something's located in quadrant 3, you should quickly look right here, because that's quadrant 3. Okay? It's like me saying, hey dude, the boat's in the ocean. Okay, why don't you go find the boat? Well, I'm hoping the next question would be, if I told you to go find a boat in the ocean, where would you go look? Huh? The last known area? What if you don't know the last known area? Dude, it's out in the ocean. If you can go find the boat in the ocean, you can have it. Huh? How many would know where to look? What could narrow that down for us? Caden?
Look in the ocean.
Yeah, you could look in the ocean. So how could I narrow it down?
What ocean?
Yeah, like what ocean, man? For those of you who don't know, there's a lot of oceans, right? There's more than one. Now, most of you are very familiar with the Pacific Ocean, since that's the one it's like right there, man, the Pacific, right? But then you go across the country and there's this other big ocean called the Atlantic. And then you go over by Asia and there's another one called Indian. Good. Okay, you have oceans. There's more than one ocean. All right, there's more than one quadrant. We locate things in Cartesian planes using quadrants. All right, may not be the best example. Okay, next piece. Right here, they don't give you points, but what I would tell you is the points you pick for x, your input values, should be able to be found on this graph. So if you find the x-axis, tell your neighbor what should your points for x lie between. All right, Cole, what do you think? Yeah, between 10 and negative 10. All right? So pick points for your input between 10 and negative 10. Now, I personally, when I have a 1/2, if I'm picking an input value, dude, I mean, as much as I like math, fractions aren't always fun to deal with. Right? So if I'm taking 1/2 of 1 or 1/2 of 2, what's the easier number to take half of? 2. Pick even numbers. Pick numbers that your bottom number goes into. If you get to choose, like I'm not picking 5 because 2 doesn't go into 5 evenly. I might pick 6 because half of 6 is 3. It makes it easier. Make it easier on yourself. Pick numbers that you can cut in half evenly. When you're dealing with a fraction, if you pick numbers that your denominator goes into, so like if you count by your denominator, that's easy. And 0, by the way, is one of the easiest inputs to ever use. Because 0 times anything is 0, and 0 plus anything is, yeah, it's whatever you started with. It's one of the easiest inputs to use. So I always try to use 0 if I can. It's my hero, man. All right. Here, number 8, I'm giving you the inputs because I want you to see the turning point. It's an x squared, so you should know the picture. Everyone draw a little picture next to number 8, what the graph's going to look like. All right. Bobby, describe what your graph looks like.
I was writing down.
Oh, okay. I wouldn't put those there. That's not it. So what's the picture look like? Is it a V? Is it a straight line? What's an x squared look like? TT? Yeah, like a swoosh. What's that? Marie? What's that? Yeah, it's a quadratic. What's the picture look like?
An arc.
An arc. Okay? A happy face, some people would say. Okay, it's a little U shape. Okay? I gave you these points because I want you to be able to find this point. All right, eventually we'll give you a formula to find that point. Not today. And then I've given you this point right here, or these coordinates right here. Put them in your input spot. On number 9, I gave you those coordinates because this type of graph, tell your neighbor what the picture is going to look like. Jennifer, what's it going to look like? Yeah, it's going to be a V, right? How did you know that, Jennifer? No. How do we know this is going to be a V? Annalise? Yeah, because it's an absolute value. All right? Because it's an absolute value. Now this is going to be a V. I've made sure that this is your turning point. This right here, the number 4, that's your vertex. You can put a big V there. That's Mr. Vogel's favorite point. Okay? And this one right here, this is also your vertex. That 0 is. Okay? Put a V there. Mr. Vogel's favorite point. Okay. Yeah, 0's my here. We've already talked about that. All right. Any questions so far? Okay. I want everyone to start today with problem number 1 on the last page. Problem number 1. There you go. Go at it. Work with your groupies. Let us know what they chose for A. All right. Go for it, Cole. I'll be writing it down so we can use my. And Jennifer, you guys. Whoever wants to talk. Go for it.
What?
You just put it under the camera. Woohoo!
We put H for hours and C for cost
Why'd you choose H for hour?
because H makes sense.
Why does it
but
make
for
sense?
the hours.
All right, I'm playing like a little coy here, but yeah, I mean, right? Hours start with H, so that's a good thing to use. Cost starts with C. That's a good thing to use. All right. Hey, good job. Well done. Okay, letter B. Letter B be going to Jaden Jentz's group. Come on down, Jaden Jentz's group. Dude. That would be Jaden and Lily. Come on up, Lily. Don't let Jaden leave you back there. All right. You guys bring your paper. Lily's got hers. All right. You guys describe letter B, our function.
Wait, I mean, I put it on the screen. Can
Yeah,
I just
put it on the
say
screen, yeah.
Okay. Ew. We said 68 plus 48, so
Okay.
y equals 68 plus 48.
Okay, what does the 68 represent?
The cost, the total cost,
The cost for supplies.
yeah.
So that's like a one-time fee, right?
Yeah.
$68 your one-time fee. Your reoccurring fee is
To 40.
the 40, depending upon the hours. So now we're missing one little piece here.
Oh.
Okay, missing one little piece, and I'll bring that up here. Good job, guys. Thank you. All right, this piece right here, where we have the 68 plus 40, that actually has to equal something. Since it says a function, that means we want to put it in function notation. Now, what do we know about function notation? Dude, function notation yesterday. What did we learn? Who? How do I know something's a function? Cole? Yeah, it's like f of x, right? You guys remember this from yesterday? F of x, that's a function. Now, we can't use f of x because we're not using x in this equation. What are we using? H. Go ahead. Yeah, it would be c of, it's not, yeah, it would be c of h. Did you say c of h, Mackenzie? Or did you say c? Yeah, you know what? Usually we would say the cost equals 68 plus 40h. But since it says function, we're saying cost is a function of the number of hours. Okay, so we write it as c of h. So whatever variable's over here, you just put in those parentheses there. Say cost is a function of hours. C of h. Now we have function notation. It says now put your variable in the table, fill in the table. All right, man. We got person one. Brennan, your group. You guys are up. Yeah, man. Woohoo! Brendan and TT. Bring it on up. All right, TT's putting hers up there. Well done, TT. All right. So we've got 40. Good. So we got the 68. We put in the 0 there. All right. We get 68. Now, how many have that table? Hey, notice. Hey, I like the way TT's put everything in. And notice when she put the values of 0 and 1 and 2 and 3 and 4 in, she's put them in parentheses there. That quickly shows us that she's substituted a value in when you show them in parentheses like that. And later on, it'll help to make sure that you didn't make a lot of mistakes. All right, very good. I am going to finish copying that real quick. So, 108, 148, 188. Everyone agree with those values? I'm not checking them. So you guys are the checkers. Is that what you guys got? Yeah? Okay, thank you, TT. Brendan, well done. All right, the next part's a little more difficult. Okay, this, by the way, the other thing TT had here that was really good, she made sure she put these values in order pairs here, which helps you with the next step. All right. 4, 228. Can we see that? All right, good. So letter D says graph the representation, use tails. Anyone know what tails means? It's not like a flipping of the coin. Caden, what does it mean?
It stands for title, axis, intervals, labels, and
Scale.
scale.
Yeah. So tails is an acronym. It stands for title, axes, intervals, labels, and scales. Now, I changed the A because I've never seen a student ever mess up on their axes. Like, they've never have forgotten to use X and Y axes. Okay, I can't figure out. So what I call A is accuracy. Okay, I change it up because I feel cool like that. So title, accuracy, intervals. What's that? I didn't hear you. It's not, well, it might be. What's the equation look like? Does it have a variable to the second power? Does it have, yep, it's linear. Okay. Intervals, label. Kinsey, do you want to do this one? Sure. All right. Do you have it already done? All right. Come on, bring it on up. Jaden will come up with you. She's pumped. What? She's excited. See? Hip, hip, hooray. Yeah, man. All right. So she has a title, CMHS Library Lights. Nice. Bright lights. Well done. Use both lights. Okay. We've got our time. We've got our cost. All right. Time, cost. We've got 60, 68, 108, 48. So you went up by how much every time?
68.
Let me, can I write on here a bit?
Yeah.
Right, cool. So things that I think we've done really well on. I'm just gonna sit down if you don't mind. All right. Things that we've done really well on. I like the title. You may want to just add the word cost. That way we're relating these. Maybe over time, when you're putting a title, you want to tie your variables together. Okay. Got our label here. Always measure, or what you're measuring in. I know that it says we're measuring in hours up here, but you want to put that on your graph. Otherwise, you might be thinking per day. Right, Jake? What you doing there, Jake? It looks like you're calling a lifeline. Cost in dollars. We don't want it to be in euros or anything like that. So making sure that we got that. Now, the problem that I have, I think x-axis, the intervals are great, going up by 1 every time. We have a good scale. That's from 0 to 8. Okay. On our y-axis, are we going up by the same amount? No. We went up by 68 the first time, which is cool. That's fine, but that means then you have to keep going up by 68. Okay, so 68, and then we went up 40. So it looks like what Mackenzie did is just went through and picked these numbers. Is that what you did? Mm-hmm. And plotted them. Okay, and that's a common thing, but it doesn't always work out. Now, this right actually here, since she went up by 68, and then how much from 68 to 108? Everyone? 40, and then from 108 to 48? 40, and then from 48 to 188? 40, and then 188 to, is that supposed to be 228?
Yeah.
228, how much is that? 40. So she actually is fine past this point, right? It's just this first one's kind of messed her up. Because it went at 68, and then she's going up by 40 every time. Does anyone know what to do to fix that? It's a real easy fix. She doesn't have to erase everything. Bobby?
Go by a lower number.
You could change what you're going up by. Patrick? Got to take out your earbud. I know you're talking to Secret Service and stuff. Very important stuff. Okay. Anyone else? Anyone ever see this? It's called a break in your graph. I'll zoom in so everyone can see that. It would be like a life size. Check it out. This is a break in your graph. All that means is you've left a little chunk of your graph out. Okay? Is that all right to do? Yep, that's all right to do. Okay, so here she went up to 68. It just means she left 28 of her graph out. Right? Now, probably if I was redoing this, I might go up by, say, 50s every time. That might have been a better interval to go up by. You don't have to use these values up here. That's like alternate. Look at that handwriting. That's beast. That's awesome. Okay? Good handwriting. Okay. All right. Okay, you don't have to plot these exact points. If we would have went up by 50, did anyone go up by 50? Can you bring me your graph? Thank you. Good job. I'm going to use I already used yours. Oh, actually use TTs. But, okay. I'll read the statement. All right. So, there we go. So, went up by 50s here. All right. And it doesn't, if you use a straight edge, you probably see a straight line. But that works out really well also if we go up by 50s. Okay, so you don't have to go up by the exact numbers. Those exact numbers don't have to show up on your graph. All right, letter E. Anyone want to volunteer for letter E? Thank you. No one wants to volunteer. Okay. Number 25, who do we got? Jennifer, you guys have already been up. It's the luck of the draw, though. I'm just doing random number tables. Jake, you have it? Oh, you just went up. Yeah, you're like, oh, well, I can't do it, dude. Brendan, do you guys have it? You got it? Can I put yours up? All right, let's check out E. I might use E and F just to get us going, okay? E and F, looks like Brendan's went through. How many hours did the electrician work for if he charged 248? So the 248 is the total cost. That gets plugged in for C. So we use our original equation up here, okay? I'm going to write C of H in here. Oops, C of H. So Brendan, I'm writing on your paper. Sorry, man. C of H equals that. Okay? So he's putting, what in the world is that? He's using an eraser, huh? C of H equals that. So plug that 248 in. That becomes your C of H. And we solve, that's 4.5 hours. Versus letter F, what is the charge if the electrician worked 8.25 hours? This time we plug that in for H. And we solve it out for 348. Anyone else do those two? No one can second that? I might be able to second it. Brennan?
It's actually 398.
398? Yeah, dude, I was going to second it there. 398, okay. Sorry, thank you, 398. That's what you had. It's just I call it 48. Good job. Hey, any questions?